Welcome. We're going to look at inverse functions. Now, I'm going to set this up with setting up a function and an inverse function. And the first thing to focus on is the parent function of linear equation, which is y equals x. That is also the line in which inverses flip over each other. And a function, let's take a function like this one. I'm going to use this point and this point, and I'm going to draw a nice line. And this one is what we call f of x. That's the main function. Now, this point here was 0 and -5. Okay. Nope, I got them mixed up. Let's get them back the right way. The x value is -5 and the y is 0. Over here, the x value is 5 and the y value is 2. The inverses of that are going to be literally the inverse x's and y's. So if I go to 2 and 5, that's the inverse of this one. And then the other one will be, now is where I'll use -5 and 0. And I'm going to draw a line between them. That is the inverse function. And we identify that as f minus 1x. That -1 here, you're used to as seeing an exponent where you then bring the number like x to the -1, you bring it to the bottom of a fraction and make it x positive 1. You change the sign. It has a different meaning here. The context here, when it's with the context, when it is an exponent of the letter f, means this is an inverse function. It's not really an exponent, it's just mathematical notation telling you that this is an inverse function of another function. Now, a few characteristics to watch for here. Notice that the two lines meet on y equals x. The second thing is that any point has its corresponding point perpendicular through y equals x, and the distances like d1 and d2, the distances are equal from y equals x to one point or to the other. So the same thing would be true here also. Call this one D3 and D4. Those distances are equal and it makes for perpendicular line. Now you don't have to memorize those things, but it does help to recognize that about inverse functions if they're linear equations here. Some similar things if they are squares, cubes, and other types of functions, but we'll get to those later. And still similar, many times they don't actually ever meet at y equals x for some of those other types. Now that idea of the variables of the x's and y's flipping, that's exactly what happens on a practical basis with inverse functions. So take this function of x, if that's -4 and 7, then the function -1 is 7, -4. So a table of values would literally change so that this would become 0 and 8 instead of 8 and 0. And this one would be -3 and 17. And that would be the inverse function when the x's become the y's and the y's become the x's. Now, here is the skill that you need to master with making the inverse of y, and we'll start with this one. I'm going to show you the steps to do this, and they're simple to do, and you just want to memorize them. The first thing is f of x becomes y. So f of x becomes y. The second thing to do is you switch the x and the y. Switch x, oops, that's not spelling switch. So get better at that. Switch x and y. Okay. And then third, solve for y, the new y. So to do that, the first thing I'm going to do is switch around or switch over here. Since they're equal, I can just put them on opposite sides as long as the same relationship's still there. You notice these are equal to each other. So if 2 equals x, then I can say x equals 2. And that's what I'm doing here. And now I've got the y on the side where if I want y equals, I need to have it over there on the left side. But I'll subtract 9. So I get 5y equals x minus 9. And now I'm going to divide by 5. Okay, now let's notice something here. X minus 9 is equal to over 5 is mathematically okay, but not good. Let's say is mathematically okay, but not good. Let's apply that 5 to both things. So that means I would say y equals x over 5 minus 9 over 5. And that's better, but it's still not as good as it should be because you can't actually see the slope perfectly. So instead, what I want this, the way I want this written is to put the 5 or the 1 over 5, because of course there's a 1 there, like there always is in front of anything. Then the x, subtract the other thing. That is the best way to write it, except that it's still not done. There is a fourth thing to do. The fourth thing to do is to replace the y with f minus 1 of x. That identifies it as the inverse. Replace y with f minus 1 of x. That's the fourth step. So you have step 1, step 2, step 3, and step 4. And here, that is our inverse function. So now let's graph these. Okay, that's the original function. We'll make it as y equals, which means we're going to go to 9 to graph the. Now let's see. I need to go 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I'm going to have to go up here to 9 because that's the y-intercept here for this problem. And then down 5. Now that's a slope of 5 over 1. Well, I can't go up 5 easily, but I can make it negative 5 over negative 1. So 1, 2, 3, 4, 5. And then a negative 1. Okay. And then 1, 2, 3, 4, 5, and a negative 1. 1, 2, 3, 4, 5, and a negative 1. It's just right here. Okay. That is f of x. Let's use black for the other one. I'll circle black to show I'm going to use black. All right. And so negative 9 over 5, that's like negative 1 4/5, or negative 1.8. That's a little bit easier to place. It's approximately or almost at negative 2. And then I have a slope of up 1 and over 5. 1, 2, 3, 4, 5. So it's a little bit above there. I can make that negative 1 and 1, 2, 3, 4, 5. And now I'm going to draw this line. And that's f minus 1 of x. And I also want to draw the line for y equals x, the inverse line. And that's what this is. And notice it has that point where they meet. And then if I were to like draw lines between the similar ones, I get, I think that is like 5. Well, yeah, okay, that would work. It's like, looks like it should be perpendicular and about the same distances between them, except for my drawing is not all that perfect. But it looks pretty reasonable there. So I have now graphed both of them. I've graphed this one and I've graphed this one, and the y equals x line wasn't really necessary, but you can see it. Now, try to do that with the next one here. You have a slope, you have a y-intercept, so do the y-intercept, but actually that's just graphing it. Why don't you first find the inverse? Go ahead and do that, and then come back, pause the video temporarily, then come back, and I will do it too. All right, welcome back. So my first step is to put y here. Okay, second thing I'm going to do is switch them. X equals 2/3 y minus 4. Now, so that was step one, that was step two. Now I'm going to, step three, I'm going to solve for y, and I'm going to start by putting the whole side with y in it over on the left. Then I'll add 4. 2/3 y equals x plus 4, plus 4 and plus 4. Now I could multiply everything by 3 and then divide it. I'll do that first. So I'll do it in 2 steps here. Multiply both sides. Gives me 2y equals 3x plus 12. And I'm going to divide by 2. Gives me y equals 3/2x plus 6. And then I have to make it where it's the function minus 1 of x equals 3/2x plus 6. Okay, let's put, oops, I didn't mean to have that go away. So that gives us, here is first the main function, then here is the inverse function. So let's graph these. I'm going to graph this one first in blue and then this one in black. I'm going to go to minus 4, and then I have a slope of up 2 and over 3. Up 2 and over 3. And I can go the other way, down 2 and negative 3. And there is, whoops, not a very good line. So I'm going to try again and do it by hand. That's reasonable. I'll take that one. And then I'm going to do one with plus 6, now in black. 3, 4, 5, 6. And it says up 3 and over 2, and that one would be easier if I do them as negatives here. So I'll do negative 3 over negative 2, down 3 and over 2 are the negatives. 2, down 3 and over 2, down 3 and over 2, down 3 and over 2. Interesting that these are not meeting, but that's because this line, it not so well drawn between them, because there should be, that black line is a little bit too much over. I think I could make that look a lot better. In fact, here is where I'll now use this so that it doesn't look as far off as it did there a moment ago. Okay, reasonably close. So these lines aren't quite parallel, but they're getting closer and closer down there. At some point, they'll both hit the red line right at the same time. So this one was the inverse function, and this was the function, and this is the inverse flipping line, y equals x, the reflection line again. Reflection line is the right term. All right, so now let's look at something different. When you get an inverse, you can graph it and see that it's reasonable, that it should be the correct thing. However, now, let me save this for everyone. Now I want it to disappear on me. Okay. Write the inverse and then verify it. We are going to prove that it really is an inverse. Okay, so let's take this inverse. In fact, let's do one here. Okay, y equals 5x plus 3. X equals 5y plus 3. 5y plus 3 equals x. 5y equals x minus 3, because I'm going to subtract 3. Divide by the 5. Y is equal to 1/5 x minus 3/5. F minus 1 of x equals 1/5 x minus 3/5. So I have two of these. I have the original, and then I have the inverse. The way you verify it is that you put one inside the other, and then the first one inside the second, and they should both solve to x. So look at this as a composition here. we're going to take the inverse function and put it inside of the function. Then we're going to take the function and put it inside the inverse function. So what this is saying is f of 5x plus 3 is equal, oh, no, it was the other one. Okay, so let's start that part over. That the function of 1/5 x minus 3/5 is equal to 5 1/5 x. Ooh, no, I need to go down because I took up some space there. Okay, is 5. I'm taking this part and putting it in. 1/5 x minus 3/5 plus 3. So now let's distribute the 5 times that. That's going to be 5 over 5x, so we get an x. And then here, that's going to be 15 over 5 minus 15 over 5 plus 3. Well, that's x minus 3 plus 3, which means we get an x as the result. Let's do it the other way. Here we're going to do where it's the function minus 1 of x, which is 5x plus 3, equals, and now I'll be using this part, 1/5 5x plus 3 minus 3/5. So let's distribute this into this. 1/5 times 5 is x. Distribute it to that. That's plus 3/5 minus 3/5. We get x. If you get it where they're both x's, both of them eventually at the same time, that proves, that's like proof, these are inverses of each other. This is proof. Okay, so that's what you need to be able to do to prove it. Okay, let's do it again. So let's use negative 3/4 x minus 1. Go ahead and take a moment to pause and do this. Find the inverse first and then check them with each other to make sure that they really true, that you really did do it correctly. Go ahead and do that and then come on back here and I'll do it too. All right, welcome back. So I am going to make y here. Make this clearer. Now I'm going to switch x and y. Now I'm going to solve for y, and I'm going to start by putting the side with the y on the left side. I'll add 1 to both sides. Y is equal to x plus 1. Now in this case, I could multiply by 4. I can also multiply by the reciprocal, negative 4 over 3. I'm going to try that this time, negative 4 over 3. So here the 4's cancel, 3's cancel, the negatives cancel, all cancel. So I just get y. But here I get negative 4 over 3x minus 4 over 3 times 1, which was that. Oh, and now I need to make it f minus 1 of x equals negative 4 over 3x minus 4 over 3. Remember, for the slope, do not make that negative 1 and 1/3. You could do that for the intercept if you feel like it, but definitely do not do it for the slope, because it needs to be a rise over a run. Okay, and then this one here. So now let's go ahead and do this, where it's the function of x will be the function, and I'm going to put in place of this x here, I'll put this new thing. Well, first I'll say negative 4/3 x minus 4/3. That's what we're going to put into it. So it's negative 3 over 4, and now I'll put it into the x. Negative 4 over 3x minus 4 over 3 minus 1. And when I do this times this, well, the 3's cancel, the 4's cancel, the negatives cancel, I get an x. When I do this, oh, the 3's cancel, the 4's cancel, the negatives cancel, that means it's plus 1, because there's a 1 left there. Now I'll subtract 1. 1 minus 1 is 0, so I get an x. Let's see if it works for the other one. F minus 1, we'll be putting this into here. Okay. That means I'll be using as my, in place of my x, I'll be using negative 3/4 x minus 1. Let's make that fraction easier to see. Is equal to the negative 4/3, negative 3/4 x minus 1, minus 4/3. So now that times that, the 4's cancel, the 3's cancel, the negatives cancel, I get x. Here, the negatives become a positive, and it's just 1 times that, 4/3. But now I have a negative 4/3, and then this whole thing becomes 0, and I do indeed get the x that both of them need. So that's proof that these are proven to be inverses. Okay, so that is how you prove that how to make inverse functions and how to prove that they are inverse functions. Hopefully that helped with understanding this and being able to do it correctly. Thank you for watching and listening.